most people have a pretty good basic understanding of the metric system. They understand that it's based on powers of 10. So the tricky part then in using it is just making sure you know what that power of 10 is, and then what to do with that 10. Or if you move, if you're somebody who uses the like just moving the decimal, do I move to the left or to the right? Which is really the same as asking, when do I multiply by that power of 10 and when am I dividing by the power of 10? Since the beauty of powers of 10 is that multiplying or dividing by powers of 10 is the same as just moving the decimal to the left or to the right. So let's try to kind of come up with a visual that can help us with that process. So if we view the metric system kind of like this vertical spectrum, and then right here, kind of in the middle, we're going to have our base units. Right? And the base unit might be meters, it might be liters, it can be seconds. There's additional units, it could be pascals or joules that we'll learn about, or you might learn about at some point during the course or during your life. But just to start with, those are kind of the ones we'll see the most common. So there's, oh, let's put in grams too, can't forget grams. So those are our base unit. And the length or amount of those is based on other things. So then we can go smaller than the base unit with a metric prefix or larger than the base unit. So if we're going smaller, we might have deci, which is 10 times smaller, centi, which is 100 times smaller than the base unit and 10 times smaller than a deci. So that's where that power of 10, we're always going down by 10. And then we have milli, which is 1,000 times smaller than the base unit, and 10 times smaller than centi. We also can go up. We can have a decameter, which is 10 times larger. We can have a hecto. We can have kilo, and on. And kilo, deci, centi, and milli are the ones you're going to run into the most often in our particular course, so I want you to pay the most attention to. So again, just to kind of review those meanings, we have, let's say, a meter. You know, and a meter is a little bit less than like someone's arm span, so kind of think that. If we have a deci, we're saying that we took that meter and we cut it into 10 pieces. So a deci is 1/10 of that original meter. A centi is 1/100th, which is 10 times smaller than even that. And then a milli is 1,000th. Even though your brain might want it to be a million, it's not. A deca, we're going 10 times greater. A hecto, we're going 100 times greater. And then a kilo, we're 1,000 times greater. So again, we're going, when we move up, we're going to a larger unit. When you add these prefixes, they become larger than the base unit. When you move down, we become smaller than the base unit. And this can kind of help us, this visualization of this vertical spectrum can kind of help us then in deciding how we're going to approach then the conversion between these units. If I wanted to convert between meters and centimeters, I can kind of use this visualization for that. Because if I am going smaller than the base unit, so let's say I wanted to do a really simple problem. I wanted to take 0.75 meters and I want to convert it into centimeters. So if I was going to approach that through dimensional analysis, I would want to go, okay, I want meters on the bottom, centimeters on the top. So I want to put what the metric conversion there is. So in every 1 meter, there is 100 centimeters. I'll parentheses around there. Now, a tricky part is kind of understanding where this power of 10 belongs. So the power of 10, the 100 in this case, when you're below this line, when you're smaller than the base unit, that power of 10 is going to belong to the metric prefix, to the centi. So it goes with the centi. As opposed to if we were taking that same, let's say we wanted to take 0.75 centimeters and we wanted to convert it into kilometers. Oops, sorry, I meant meters here. We wanted to convert it into kilometers. I would go, okay, I want meters on the bottom, kilometers on the top. It is not true that there are 1,000 kilometers in a meter, so I have to set it up right. There's in every 1 kilometer, there's 1,000 meters. Parentheses around there, you can see my units would cancel out and I would have the unit I wanted there on top. So one important thing to note right here is that when you are below, when you're converting to a number, when you're below the base unit, the power of 10, the 100, the 10, the 1,000, belongs to the metric conversion. So it belongs to the centi in this case. And if we were going into deci, it would belong there. We would have 1 meter is 10 decimeters, or 1 meter is 1,000 millimeters. But when you go above the base unit, it reverses. That power of 10, the 10, the 100, the 1,000, needs to be placed with the base unit. Because it's really easy to accidentally go, okay, I know that kilo means 1,000, so 1,000 kilometers in a meter. And I don't even think people do that, like thinking that. They're just throwing in those numbers. They know it's 1,000, but the 1,000 actually in this case needs to belong to the base unit, not to that larger metric. So when we're below, it needs to belong to the metric prefix. When we're above, it needs to belong to the base unit. So let's take a look then at how this changes the math. When we're going smaller, you're going to notice that we're going to be multiplying by that power of 10. We're going to be multiplying by 100. We're going to be multiplying by 10. We're going to be multiplying by 1,000. And obviously, that's assuming that this is how you're setting it up. If you are setting it up differently, you might you might run into something different. This is how I'm going to be setting it up. So we would be multiplying, and when you multiply by a power of 10, that's the same as moving the decimal to the right. So decimal moved right. So, and here's my decimal, and I would move it to the right as many places as there are zeros in the power of 10. So 0.75 meters is the same as 75 centimeters because I move the decimal place to the right. If I'm larger, notice that we would actually be dividing by that power of 10. So dividing by power of 10. We'll just say tens, because we have powers of 10. When you're dividing by a power of 10, and you can check this in your calculator, it's the same as moving the decimal place to the left. So the decimal moved to the left. And it moves to the left the exact same as we do when we're below the base unit. It's just based on the number of zeros in the power of 10. So in this case, I would go 1, 2, 3, and fill those in with zeros. I always put a 0 in front just in case that looks like a little, like a speck on my page. So this one has a little bit of alliteration, which I like, in that larger and left both start with the same letter. And so that can kind of help if I'm trying to figure out, am I moving the decimal place to the right or to the left? Because that really matters. Moving it to the left is making that final number smaller by powers of 10. Moving it to the right makes it larger by powers of 10. And if you think about, like, would you like your paycheck changed by powers of 10? Yeah, I would like it in the larger way, not in the smaller way. So it definitely matters when we go to do our converting. So when we are above the decimal, or when we're larger than the base unit, that power of 10 number really belongs to the base unit. There are that many base units in our new larger metric prefix. When we are below the base unit, that power of 10 number belongs to the smaller metric prefix. So there are 1,000 millimeters in a meter. There are 100 centimeters in a meter. Whereas when we get above, the base unit is the one that gets the power of 10 number. When we are moving from the base unit to one of those larger ones, or if we're even down here and we're moving up, we're going to be essentially dividing by powers of 10, which is the same as moving the decimal place to the left. If we're smaller, we're going to be multiplying that decimal. We're going to be multiplying by powers of 10, which is the same as moving the decimal place to the right, the number of zeros needed. So I hope this visualization helps a little bit. Really, the trickiest part of metric conversions is making sure you know what the metric conversion means relative to the base unit. It should always be a power of 10 relative to the base unit. And they're going to be powers of 10 relative to each other as well. And then knowing then, will I be dividing or multiplying by that power of 10? And if you want to then just move the decimal, does that mean to the left or to the right?